The vast majority of these seismic events were even determined to be related to the movement of underground fluids, specifically being known as long-term hybrid events. These events were centered primarily at 8 to 12 kilometers depth beneath a lava flow and vent emplaced by a tephritic eruption in 1798. This all encompassed what was one of the strongest earthquake swarms the Teide volcano produced since its last erupted in 1909. So, does this mean that just like the island of La Palma 3 years prior that we are soon going to witness a destructive volcanic eruption? To this I answer almost certainly not. All of the earthquakes which struck during the last 48 hours were very small in magnitude, with the largest specific event registering in as only a magnitude 1.6. In other words, far too small for a person to feel even if you tried right above its epicenter. In fact, since monitoring began at this volcano, the Teide volcano has produced 118 such earthquake swarms, with swarms generally occurring at a rate of about once or twice a year. However, the aforementioned statement is slightly deceptive. While yes, that many earthquake swarms have been measured, only a very small fraction of these, specifically 5 including the swarm which just struck specifically encompassed an abundance of long-term hybrid earthquakes. And, oddly enough, all of these 5 events have occurred since 2016 began, specifically on October 2, 2016, June 14, 2019, June 16, 2019, July 12, 2022, and November 14, 2024. And, these all events occurring in the last 8 years is not simply due to the emplacement of new or improved sensors around the same time that could better detect these events. Rather, while this is still highly speculative, 2016 seemingly signaled when a new batch of magma began accumulating in both the uppermost mantle and lowermost crust underneath the Teide volcano. This is seemingly occurring at a low rate, only generating earthquake swarms when hydrothermal fluids and gas heated from the magma become pressurized at depth. In other words, my best guess is that if you were currently view the interior of the Teide volcano along with its northwest rift zone, it would currently look something like this. This statement is speculative once again, but the magma is likely quite mafic, aka low in silica, probably with a composition of trachy basalt, and is not located in Teide's northwest rift zone which itself last produced an eruption in 1909. Instead, it is occurring within the large 15.5 kilometer or 9.6 miles wide caldera of the volcano, meaning that in the highly unlikely event an eruption did end up occurring here due to the current unrest, lava would only flow towards completely unpopulated or sparsely populated regions. Regardless, notice how in my model that the potential magma is only accumulating at 12 kilometers depth like it has been for several years rather than pushing further upwards. This is quite common at volcanoes even during background activity, and the vast majority of similarly emplaced bodies of magma will never be erupted onto the surface. This is also the most likely fate by far of the magma involved in the current earthquake swarm, hence why the Teide volcano is remaining at its normal alert level of green, since no other unusual activity has been measured. This is merely an event which has occurred once every 19 months on average since 2016 began. This is not a cause for alarm unlike the rapid escalation which occurred at La Palma 3 years earlier. At La Palma, it involved far more and far stronger earthquakes that occurred alongside strong ground deformation. Since no ground deformation has been detected, on my 0 to 10 opinion-based volcanic unrest scale, I would currently just barely place the Teide volcano as a 2. As a final note, I would like to thank my new YouTube channel member Dragons and Dragons for supporting